All right, class, we're going to continue. Now we got the triple system of equations. So for this one, let's see, okay. For this one, x is already equal to 3. So since x equals 3, I already know that. So 3, comma. I'm going to plug in the 3 here. So 5 times 3 plus 2y equals 11. 15 plus 2y equals 11. A little bit of algebra. Y equals negative 2. So negative 2, comma. Then we're going to keep plugging in here. 4 times 3 plus 5 times negative 2 minus 5z equals negative 3. 12 plus negative 10 is 2. So 2 minus 5z equals negative 3. Z equals positive 1. A little algebra, yeah. So it's 3, negative 2, 1. Usually we write it like this. If you write x equals 3, y equals negative 2, z equals 1, that's totally fine. Now for 7, we have a triple 1, a triple thing. Now I could do the row reduction and all that, but you know what I'm going to do? I'm going to use my calculator for this. So I'm going to pull up my calculator, and from the last video, you should know I could do a matrix. So I'm going to go to matrix, which is second x to the negative 1. I'm going to go edit. I'll edit A again. In this case, because we have 3 variables, it's going to be a 3 by 3. Very important, you got to make sure if you're going to be consistent, the x's are first, the y's are second, the z's are third, okay? So this is going to be negative 1, negative 5, 1. Negative 5, negative 5, 5. And then 2, 5, negative 3. That's positive 2, 5, negative 3. So that is my x, y, z's. Then I go second matrix again. I'm going to go to the B version. Now I want my answers. So I want 3 by 1 because I have 3 answers, which is 17, 5, negative 10. All right, second quit. From here, I want to go second matrix. Now I'm not going to go to the edit on the right. I'm going to go to names. And I'm going to go A, 3 by 3 to the negative 1 power times second matrix, my B. 1, negative 1, negative 4, negative 4. Your answer is going to be, if you put x's in the first column, it'll be x on the top. If you put y's in the second column and z in the third column, it should be x, y, z. So it's going to be negative 1, negative 4, negative 4. If you want to go over how to do it the long way, you can check out my older videos. All right, for this one, let's set up the equations. So tropical punch, we got bananas, oranges. I'm going to use R for oranges so it doesn't look like a 0. And papayas. You don't know how much you need to put of each fruit, but you know there are 7 pieces in total. So I know B plus R plus P equals 7. And there's twice as many oranges as there is bananas. So if I had 1 banana, I should have 2 oranges. If I had 3 bananas, I should have 6 oranges. So whatever my banana is, times 2 is going to be my oranges. You also know that 7 pieces of fruit cost $5.25. So I know the total should be $5.25. Bananas cost 50 cents each, so I pay 0.5 for every banana. Oranges cost 0.75 each, so 75 cents, so 0.75 R. Plus papayas are 1.25 each, 1.25 P. With the information, how am I going to find banana, oranges, and papayas? Again, you can look at my old videos for the long way. If I want to do it matrix version, I have to make sure I put it all in the order. So I'm going to have to move the bananas to the left side. So the top will still be the same. Banana plus oranges plus papaya equals 7. This is going to be negative 2 banana, oranges plus orange. There's no papaya, so I'm going to leave that blank on purpose, equals 0. And then over here, 0.5 banana plus 0.75 orange plus 1.75, 25, my bad, papaya equals 5.25. Okay, with that in mind, we're going to set the matrix again. This time I'll do it in letter C. So it's going to be a 3 by 3 matrix where the top column is 1, 1, 1, 1 banana for 1 orange for 1 papaya. Here, it's going to be negative 2b plus r plus nothing. So negative 2 bananas for my every 1 orange for no papaya. So I'm going to keep that 0. And in here, 0.5 bananas for every 0.75 oranges for 1.25 papayas. Second quit, second matrix. We're going to go to letter D. Let's click option 4. Letter D, which is a 3 by 1 now. And the answers are 7, 0, 5.25. Okay. Second quit, second matrix. I want C to the negative 1 times D. 214. So that indicates I have 2 bananas. Remember, since I put bananas, oranges, papaya this way, my answer is going to be banana, oranges, papayas this way. So there is 2 bananas, 4 oranges, 1 papaya. Again, you're free to do it the long way if you wish. All right, graph the following inequalities. So we're going to graph this as a parabola. If you want the generic for the parabola, it's a x minus h squared plus k. So this is, and then h and k is going to be the vertex. So this means that h is positive 2, k is negative 1. So that means my vertex is at 2, 1, and I'll graph my parabola. I should hit there actually. Okay. Then the second part is I need to check if it works. So I have to pick a test point. So I'll test with 0, 0. Again, you could test with any point. Like if you don't think 0, 0 is clear to you, test somewhere like here, 2, 8, to clearly say that's in the middle. So 0 is less than or equal to 4 minus 1. 0 is less than or equal to 3. Is this true? Yeah, that's true. So because that's true, it must be shading on the outside. This one, this is a circle where the circle, generic circle one is x minus h squared plus y minus k squared equals r squared. And then here's a straight line, which is y equals mx plus b. So for the circle, our center's at 0, 1. So 0, negative 1. No, 0, 1, my fault. So 0, 1 up here. Here's the center of the circle. And then my radius is 3 because it's r squared is 9. So the square root of that is 3. So I'm going to go 3 up, 1, 2, 3. 3 down, 1, 2, 3. 3 right, 1, 2, 3. 3 left, 1, 2, 3. Make a quick circle. That's not how my circle, I wanted my circle to look like. There we go. And here we'll do a straight line. So y equals x of b, so b equals 2, m equals 3 over 1. So I'm going to go 2 up. And I'm going to go through, since my slope is 3 over 1, that goes 3 up, 1 right. 3 up, 1 right, or the other way around. 1, 2, 3 down, 1 left, 3 down, 1 left. All right. Either way, we want a test point. We need some kind of test point. So let's do 0, 0. So I'm going to plug in 0 for each one. So the top one, if I plug in 0, 0, I get 1 is less than or equal to 9, which is true. So I know it's going to be on the inside of the circle. And then this one is 0, 0. So 0 is less than or equal to 2, which is also true. So it's going to go towards the dot below the line. The arrows intersect here, so we're going to shade this area. Here, this is a straight line at y equals 2. So y equals 2, so y equals 2 is over here. So it's all my y values equal 2. X is equal to negative 3. So x being equal to negative 3. 1, 2, 3. All my x values are negative 3. And then this is 3y minus 2x is less than or equal to 6. To make my life a little easier, I'm going to rewrite this as y. Okay, so you do it right. Y equals 2x over 3 plus 2. Because I'll divide 3 by everything. Which means my y-intercept is at 2. And then I would go 2 up, 3 right. 2 up, 3 right. And the opposite, 2 down, 3 left. 2 down, 3 left. Okay, let's put a test point again. We could use 0, 0 if we want. So y is less than 2, or y is greater than 2. So if you plug in 0, 0 is greater than 2. That's false, so we're going to go up from here. 0 is greater than or equal to negative 3. That is true, so I'm going to go towards the truth. And then plug in 0, 0 here. 0, oh, I'm sorry, this should be less than or equal to. Yeah. So 0 is less than or equal to 2, which is true. So go towards here. So the overlap, even though this arrow looks like it's here, it technically goes all the way through. It goes all the way through. So the overlap is over on this side. The overlap is over on this side. Okay. Are we on the last test already? Oh no, we're second to last test. Okay. Here, let's give the focus directrix of this one. This is parabolas. On a test, I believe I give you in parabolas, like I tell you this is a parabola, so you don't have to even think about it. On the test for the graphing one, for sure, you're not going to have to change it. For the graphing one, it will be already in the right form. So let's set it in the right form. In the right form, we want the x's, since the x squared is here, we want all the x squares on one side and everything else on the other side. So I'm going to move it, so 2x squared plus 4x equals negative 3y minus 14. So I move my x's to the left and I move all my other things to the right. I want the x squares to be by itself. So I'm going to divide a 2 from everything here. I'll take a 2 out, I guess I could say. X squared plus 2y. Now I need a perfect level letter C. So plus C somewhere equals the rest. But when I do that, negative 3y minus 14, I need to do a plus 2c because of that thing on the outside. Okay, the perfect C, cut it in half, which is 1. So this will be 1, which means I'm going to be adding a 2 over here. Which now is going to be rewritten. 2x plus 1 squared equals negative 3y minus 12. I'm going to factor out negative 3 here. So negative 3y plus 4. Then I'm going to move the 2 over here, so my p-value is over here. So it's going to be x plus 1 squared equals negative 3 over 2, y plus 4. Okay? All right. Vertex is hk, so negative 1, comma negative 4. The focus, which is negative 3 over 2, that's going to give me my p-value. So negative 3 over 2 equals 4p. So divided by 4 on both sides is negative 3 over 8. And since it is the x that's being, or the y is by itself, is to affect the y. So I'm adding negative 3/8 to 4. So negative 1, comma, negative 4.375. The directrix is to subtract the p-value. So negative 1, comma, so it'll be plus 3/8. So it's going to be negative 3.625. Oh wait, it's not a point, my fault. It's just a line. So y equals. Take out a 3. Yeah, this thing's correct. All right, so let's continue from here. Negative 1, negative 4. So left 1, down 4. 1, 2, 3, 4 is the vertex. The focus, which is barely a little bit past it, it's going to be over here, a little below it. The directrix, which is barely above it, over here. And then the line itself will be from here facing downwards. Here, give the equation for parabola that is a focus 3, 5, and the directrix is x minus 1. So if the focus is 3, 5, and the directrix is negative 1, x equals negative 1. On a graph, it would look like the negative 1 is over here, or a line would be here, and the focus will be here. So the vertex should be somewhere in between. The vertex should be somewhere in between. So if it's between negative 1 and 3, the vertex is going to be 1, comma 5. So this will be the vertex. And we can figure out the p-value because 1, comma 5, this has a distance of 2. So p equals 2. From there, and it's affecting the x, so I know it's going to be y. So y minus 5 squared equals 2p, p times 4, 2 times 4, which is 8, x minus 1. And again, I'm just going to go through this video fast because I have longer videos, so you want to look up the old ones for more details. Here, I'm going to rewrite this. X squared plus 6x plus 9y squared minus 90y equals negative 225. I'm going to need a plus c here, and then I'm going to have to factor this 9 out. So y squared minus 10y plus c sub y sub x. Negative 225. So here I need the cx plus cx plus 9cy. So the cx here, cut it in half. 6 is 3, squared is 9. So this is going to be 9, so I'm going to add a 9 here. And then cut this in half, which is 5. Square is 25. 25 times 9 is 225, so 225. So we're going to condense all this. So x plus 3 squared plus 9 y minus 5 squared equals a 9. But the equation has to equal 1 on the right side, so divide everything by 1. Or divide everything by 9, I should say. When you do that, this would just become 1, this would just become a 1, and that would just stay over 9. So plus that equals 1. If you want to, you could leave this over 1 to help you visualize what it is. Okay, we have the equation. So what's the center? X is a negative 3. Y is positive 5. The major vertex is based off the biggest one, which is the x in this case. So it's going to be, the a value is the square root of here. So that's going to be plus or minus 3. And it's going to affect the x value. So it's going to be 0, 5 and 6, 5. The minor vertices, or the co-vertices, sometimes it's called, it's y equals negative 5. starts at -5, but it's plus or minus 1. So b is plus or minus 1. So here we're going to have, we're going to affect the y value. So -3 plus 1, which is 6, and -3 minus 1, which is 4 over here. Plus 5 on both of them. The foci is the c value. To get the c value is a squared plus b squared equals c squared. I'm sorry, not plus, but minus. So 9 minus 1 equals c squared. 8 equals c squared. You have a calculator if you need to do it, but it'll be about 2.8 or 2.9. So the c value is 2.9 or 2.8 plus minus. So then, because the major was the x, we're going to do it to the x. So it's going to be like 0.2 comma 5 and then 5.8 comma 5. Okay. -3 comma 5, 1, 2, 3, up 5, 1, 2, 3, 4, 5. It's 3 wide, so I could go 3 to the right, 3 to the left. It was 1 tall, so 1 up, 1 down. And the foci, which doesn't really matter, but it's here and here. Then connect the exterior dots. Give the equation for the ellipse that the major vertices are this and the foci are that. So the major vertices, so the distance between 11 and -15 is a total of 26. But remember, we want the center of this, so half of that is 13. So the a value equals 13. And then over here, the distance between 3 and -7 is 10, but we want half of that, so it's actually 5. So the c value is plus or minus 5. But in the equation, we need a b value. So we need to find the b value. So 13 squared minus b squared equals 5 squared. A little bit of algebra, b equals plus or minus 12. Since the y values are the ones being affected, I might have said x values earlier, apologize, but y values is affected is going to be y. Oh, I need to find what's the middle. So in the middle of 11 and 15 is -2. So y plus 2 over the a value, which is 169, 13 squared is 169, plus the x values. You could tell the x value is going to be 3 because it's going to be on that line. So x minus 3, well, these should be squared, my fault, over the b value, which is 12, so 144, and that equals 1. Hyperbolas. Find the center. I already had it in the correct form. So the center is 2 comma -5. The vertices. So the vertices are just considered the major vertices, but there's only one that we really care about, which is the major one, which is the positive one. Not necessarily always the biggest value, but 9 is bigger than -4, but it's the positive one. So the a value is plus or minus 3. So because of that, the a value is plus or minus 3. That means I'm going to add and subtract 3 from the x value. So that's going to be 5 comma -5. And -1 comma -5. The foci, this is a squared plus b squared equals c squared. A little bit of algebra. C squared is going to equal 9 plus 4 is 13. So the square root, c is about plus or minus 3.5-ish, probably 3.6. So c is plus or minus 3.5. So we just add that to the x value. So 5.5 comma -5 and -1.5 comma -5. The asymptotes The asymptotes, I just want the slope. So when the slope comes around, I just want that y value over the x value. So 2 is the y value. When I say the y value, I mean the square root here, the b value, over 3. And the center will always be the center. All right, so 2 comma 5. So 2 to the right, 5 down. 1, 2, 3, 4, 5. 5 comma negative 5. 1, 2, 3. Wait, 3 to the right. 1, 2, 3. 3 to the left. 1, 2, 3. The foci somewhere in here in the middle, or beyond it. The asymptotes is going to be 2 comma 3. So go up to right 3. Up to left 3. Down to right 3. Down to left 3. Okay. And then you make your lines. Should match here and here. Should match here and here. Give an equation that the vertices are this and the foci are that. The vertices here, well, the vertices are here, so the center must be in between 3 and negative 5. So negative 5 comma negative 1. And the a value, since the distance between negative 1 and 3 is 4, the a value is 4. The foci, it's the distance between the center and the foci, which is 4 to negative 1, so the c is 5. So we need the b value for the equation. So a squared plus b squared equals c squared. 4 squared plus b squared equals 5 squared. A little bit of algebra. B equals plus or minus 3. So since the vertices are on the y value, we know the y is going to be the first thing here. So y minus, or plus 1, because it's negative 1, squared, over the a value, which is 16 in this case, minus the b value now, which is here for the x's, x plus 5 squared, over the b value squared, which is 9, equals 1. All right, we're on the last test. Use the graph to find the limits if they exist. So for the first one, we're coming from negative 4, or we're coming to negative 4. We're approaching here. It looks like we're approaching at y equals 2, so there's going to be a positive 2. From here, it looks like if we get over here, it looks like I would land at 3, so the y equals 3. Let's make this smaller. Okay. They don't match. So because they don't match, it does not exist. And then x of negative 4, it's where the solid dot actually exists, which is 2 here. All right, next one. From negative 2, looks like I'm approaching here. I'm approaching at y equals negative 2. I'm landing near negative 2. Approaching here, looks like I'm landing at negative 2. So since I'm both sides approaching at negative 2, looks like my overall limit is negative 2. And my dot is actually at negative 2, so negative 2. And this should be f of negative 2. My fault on that. This one, go into 3. From the negative side, it looks like I'm landing at negative 2. Coming from this side, looks like I'm landing at negative 2. Overall, I'm landing at negative 2, but my solid dot actually exists at negative 3. Remember, the limit has to be the same on both sides. All right, for this one, what is the limit? Here, it looks like it's approaching from infinity. It's just growing over and over. Over here, it's approaching to infinity. It's growing forever and ever. Now, the limit overall, I will put infinity. That's the answer I expect you to know, especially for next year when you learn calculus. You're going to learn it as infinity. But another acceptable answer is D and E. So you could argue that it does not exist. Both answers are okay. And I think on the final, I will remind you guys, but on the final, there's a question that has this type of graph, and it's going to have both of these. Both options will be okay, so you can circle both of them. Or I'll say it during the final, just to make sure. All right. According to the table, the limit of x approaches -4. So what does it look like as approaching between here? 2.5. As x approaches -2, so your x value is -2, what does it look like as approaching here? Looks like -9. Evaluate the limit if they exist. Show credit. So we plug in -3 just to see if it works. 2 times -3 equals 9 minus 1. -6/8, which is 3/4. -3/4. Hey, that just works. So if you could plug it in, just plug it in. Plug in cosine of 0. Cosine of 0, make sure you practice your trigs, not only for this part, but for the trig section of your whole final. But cosine of 0 is 1. Here, cube root of 10x minus plus 7. 2 times 10 is 27. The cube root of 27 is 3. Limits are really nice when they work. Plug in 0 here. So it's the square root of 1 over -4, which is just 1/4, or -1/4. Here, we're going to plug in 7. So it's going to be 0/0, which is a big issue. It can't be 0/0, so let's see if we can do anything about it. X minus 7, let's rewrite the bottom as x plus 7, x minus 7. Hey, x minus 7, cross those both out. 1 over x plus 7 equals 1. I'm going to plug in the 7 now, so 1/14. Again, I can plug it in as soon as it makes it okay. I don't need to do everything. Here, I have a big problem. I have a bottom here. I want to change that. So it's going to be 3 plus x plus root 3 over here. Same thing on the bottom. 3 plus x plus root 3. On the top, I do not want to distribute the x, so I'll just leave it separate. Square root 3 plus x plus root 3. On the bottom, I will FOIL this, but because there are a difference of squares, I can square the first term, which is just 3 plus x. And I can square the second term, which is square root 3, which is going to be a minus 3. Well, 3 minus 3, they cancel out. And then, because I have an x on the top and an x on the bottom, they cancel out. Which means now I'm left over with, on the top, 3 plus x plus root 3. Wait a second, I could plug in a 0 here and not cause a problem. So I plug in a 0, root 3 plus root 3. Don't get confused, it's going to be 2 root 3. Trust me, one of my fake answers is going to be root 6. Another fake answer is just going to be 3. But don't fall for those, it should be 2 root 3. Okay, check if the limit exists to this piecewise function. So if the limit approaches 2, and this is where 2 is, we need to check from the left side, and we need to check from the right side. This is technically the left side. So I plug in 2 here. It looks like it would land at -2 times 2 is 4. 4 minus 1 is 3. And if I plug it in 2 on the bottom, -2 plus 4 is -2. They don't match. They don't match. It's like one is landing here and the other one's landing here. They don't match, so the limit does not exist. Oh, I'm done. All right, guys. I hope all these videos helped. Use it to your advantage. If I made mistakes on the video, forgive me. But I was trying to get 100 on 6 tests in a row. That's kind of tough. But either way, ask me any questions, email me, let me know. See you around. Good luck.